Hi and welcome. This time around I thought I'd take a brief look at pneumatic pistons, and I know almost nothing about them, and I thought a good way to learn would be to buy some inexpensive ones and play around with them. I actually have a project where they could do some really interesting things for me. I basically need to be able to press some parts together with a reasonable amount of force. So this was the first one I found, and it was used, and it was like 20 bucks. So this one works in the way I expected, meaning the piston is retracted, and so if I put air on the opposite side, it extends, and if I put air on the top side, it goes down. And this one, I bought it sight unseen, and I didn't know the model number. I mean, they put it on eBay, but when I looked this guy up, I had a hard time finding out much information about it, and this one was the same problem. It actually was some custom part number. I mean, I could find both companies, but I couldn't find the part numbers. So this guy was too big for my purposes, although I could probably make it work. I was looking for this little guy, except this little guy is just really short throw. And it also has some other features on here, these side adjustments, which control the rate at which air is allowed to, the amount of damping that's in the retracting. So this one's also spring loaded. So here, it wants to see how it slowly comes back on its own, but the range of motion is like ½ an inch. It's not very much. And I was wondering if I could modify this to be a little more useful. So the damping feature is kind of nice, so you can control how fast it comes in and out like this. And all it is that on this side, on both these sides, there is a spring with a ball bearing behind these nuts, and as a matter of fact, no reason I can't show you. And all that does is a one-way valve, so it allows you to put air in at a decent rate and then have it stop. So you can see tiny little spring, ball bearing. That's basically a one-way valve, and that means when you're filling it, the air goes in, but it can't come back out. Because the air going in here goes to a passageway on the bottom side of the ball bearing, which pushes up against the spring. So the air coming in pushes the spring, the ball bearing up, and compresses the spring, and then fills the cylinder. When you let off pressure on the intake side, then the pressure in the cylinder pushes back on that ball bearing and seals it. They've got another passageway on this side that has the equivalent of sort of like a pin valve, and that controls how quickly the air can leave. So right now there's almost no damping. And there's a big spring in the bottom, and if I tighten this guy down, there's almost closed, and you can see it's moving very, very slowly, and as I turn this, lets the air come back out. That's kind of a neat feature. I don't know if I'm going to use it, but it's kind of handy, and it's a nice feature to have. You can always dial it out to 0. However, the range of this, as you can see, is pretty tiny. And so, looking at this cylinder size, seems like it should be able to handle a lot more range. So let's take it apart and see what we can find. So, the way this guy comes apart, it has some shafts threaded into the front mounting plate, and on the rear, it has the shaft's going to a threaded nut. So basically it's a shaft with threads on both sides and these nuts that allow you to tighten the whole assembly. Let me pop this guy off here. And the spring isn't super tight, but I'd like to remove the spring because I don't want it to essentially remain in one position. This isn't the kind of actuator I was looking for. And taking the spring out is easy enough. So there's your seals, there's the 2 entry paths. One's going into, this one is the fill, and this is the empty, and there's the pin valve blocking that off that controls that rate. So here is this guy, and that one's threaded into the bottom. The nut has fallen here somewhere. Alright, I'll have to find it. Oh, here it is. Okay, so there's just one of the nuts that goes into the top. That's kind of cool. And here's the spring to force the retraction, and here's the cylinder, which is just aluminum that looks like it's been ground. That's about it. It's not, and it's extruded, so maybe it's not even ground because it looks like it's extruded aluminum, not the kind that is well rolled with a seam in it. It's been welded. So the piston assembly is pretty straightforward. It's just on a shaft, and you can see this limits your motion here. And the piston itself was threaded on, so the shaft is threaded and the piston itself was threaded onto that shaft. It looks like there's a custom wrench they made that would fit on the cylinder side and tighten this down. Now what I want to do is I want to remove this rear section here so that I can get at least this much extra range, because it looks like you should be able to get most of the range, at least 1.5 inches from the size of this piston. So let me see if I can get the piston off of here without damaging it, and then I can cut off the rear end of the shaft. I may end up destroying this thing, but it wasn't terribly expensive, and it's a good learning experience. There's the seals for the aluminum tubing, which makes you think immediately that you could probably make one of these without too much trouble. A little bit of practice and some knowledge, and you probably get away with it. So let's see if we can get this guy off without damaging it. So I had a bunch of these old-timey spanner, dedicated purpose spanners. None of them were quite the right size. This is a general purpose one, and so maybe I'll have to make one, because you need something roughly the diameter, or ideally I guess exactly that diameter, that can hook into one of those balls and rotate it. So I'm trying to find the diameter of this hole. I went with my pin gauge set. The small ones particularly are inexpensive for the non-American brand, I guess. And it looks like the hole is pretty close. Right on the money to 1/8, so I can use a 1/8 inch pin. So let's make a spanner to get that off. So here we are on my Baxter Verticut rolling sauce, and we're going to start by trimming some material that's too wide. We're going to make it thinner, approximately 1 inch, and we're going to try cutting in a strange way that I'm not sure is reasonable. I could always use this as a regular bandsaw and push into the blade, but the way this is set, it's going to be pushing into the fence, and all the force for the cutting is going to be pushing down into the table. So with a C-clamp, I think it should be good. You have 2 points of contact on this side, one over here. That is 3 points in that direction, so we'll see. It might be a mistake, but let's give it a shot. So let's try this cut. Hopefully the clamp and everything are far enough out of the way. And the part feels secure. Well, that answered my question. It ran into the C-clamp on this side, so maybe I need to mount it the other direction. So let me flip it. Alright, let's see if that one works without hitting any of the saw parts. really wants to cut like butter. Well, it worked like a charm. So there's my waste piece, and it looks like it didn't move at all. Here's the piece we're going to make the tool out of. So I could have cut my 3/4 inch hole with the center right along the top axis, but then that would have meant my pin, which had to be perpendicular to that axis, only halfway into the top material, and it wouldn't have any support at all. So I had to shift the center of my cutting axis down to about 1/4 inch. So the first thing I'm going to do is I found my my center here, and I found my edge, and I am going to drill my 1/8 inch, drill and ream an 1/8 inch hole for the pin that is going to engage the material, and that'll be down 1/4 inch. So first we're going to center drill. Peck at the hole. We really don't need to go very far in. We just need to go far enough in that it'll intercept the 3/4 inch cutout circle we're going to put in the end of this. A single 1/1000th undersize. Run this in back here. So I found my corner that's my new 0, and I just need to come in this direction on the x-axis 1/4 inch, and that will line up the 1/8 inch dowel pin hole and the perpendicular axis of a 3/4 inch hole. Now it will leave me a little pip of material here, because 3/4 would cut a 1/4 circle out if I was right at the corner. Since I'm over, I'm going to have a little bit of material in the middle that I will have to go file off after the fact, but that's okay. That'll give some meat to the pinhole that I'm doing. Now I'm going to try and drill this very gently with an annular cutter. This isn't 3/4, so I'm going to try and take off most of the material with this. This is just under 3/4 by 1/16, and then I'll follow up with a 3/4 inch end mill, and hopefully that'll work out. So I have very limited experience with annular cutters, but they look like they cut pretty well. So we're going to try a very slow 180 RPM cut here, see how it works, especially since the end of this isn't terribly well supported. But it's fairly thick material, and it just doesn't seem like it should be too much of a problem. So let's give it a shot here. Oh yeah, it's cutting pretty nicely. Almost no pressure. Which is what I want, because I don't want the material on the end of this to deflect. And we're through. Just that easy. Alright, so now we need to step up to 3/4. And in order to do that, I think I'm going to have to go switch to an end mill. Next up is a 3/4 inch end mill. And we're going to go pretty low speed with this. And I think we could use some more altitude. All right. Perfect. Beautiful cut. Very, very nice. Okay, so see, here's the little lip I was talking about, and it needs to be straight from the center of the 1/8 inch hole. So besides threading the cylinder on, or the piston on the shaft, they also pinned it in place. So besides the tool to unscrew it that I made, I also needed to push the pin out. So I used 2 V-blocks on my hydraulic press with a pin slightly undersized and just pushed it out. It came out very easily. So using my spanner, my homemade spanner, I am unthreading the shaft out of the center. Oh, it's actually in 2 pieces. That's interesting. Bottom half and top half. Didn't know that. Huh. Okay. Well, that was interesting. So, sounds like I can just unthread the bottom half here and remove this piece, and I'll be golden. I can just put a little stud in there and we'll be good to go. So, I loosened this guy up. It looks like they used Loctite on it, permanent Loctite. And so we're going to remove this piece and we're going to add a stud to the bottom, or actually I think I get away with nothing. And I need to tighten this one back in because I loosened it. I didn't realize it was 2 pieces. That's an interesting approach because you take this guy off, now you've got a full range piston. If you want to limit it, you put this guy on. So that's kind of neat. Anyways, we're going to use the spanner here and just give this guy a snug. And, oops, wrong way. And we should be good to go. We can reassemble the piston and we should get full range. I was thinking about putting some sort of rubber bumper in the bottom. That seemed like it might be a good idea. So also I had to clean some debris out of there. So I finished this guy and got this part unscrewed, but I was just thinking to myself, why don't I just give myself even more space right here for the piston to go to the bottom by making a whole new piston that doesn't have the center section. I just need to make the proper grooves for these gaskets or seals, whatever they're called for hydraulic pistons or pneumatic pistons. I could just push that pin out again and I could make a new one. And then I'd get even a little more range, plus it's probably going to be fun, so let's try it. So in planning to making the new piston, I was just looking at dimensions. I noticed first of all that the piston diameter is probably not critical, and it doesn't need to be a tight fit. As a matter of fact, it's really sloppy in the cylinder, and that's because all of the contact is made by the piston rings, or whatever these are actually called, these gaskets. So the important part is probably the width of these grooves and the depth. So that's what I will focus on. And then I can make a part that's probably a little more than a 1/4 inch shorter. So I'm going to take some dimensions and I'm going to go over to the lathe and I'm going to make this part. Here's the original piston. Here's my new piston. So see, I'm going to get about a 1/4 inch more travel. And I had to make a second one. This was my first attempt, but I wasn't careful in measuring. It turns out that these outer 2 ridges need to be like 5/1000ths lower than the center ridge, which still is short of inside of this tube, but it does fit very nicely and should give me more travel. So I'm just going to reassemble this guy real quick, and we'll give it a try out and see how it works. So this side is going to go in here. Alright, so let's see how it works. So you can see I've got some really nice range of motion now, much better than the 1/2 inch originally. So that was a fun little project, and I learned a lot doing it, and I'm sure there's a lot more that I need to learn. The piston's relatively smooth, but I might have been able to do just a little bit better job. I'm not quite sure. Well, I think it's likely sure if someone who really knew what they're doing was here to tell me. Let me remove these dampening things here. So that's pretty good. So there's my project. Thanks for watching. Hope you liked it. Hope to see you next time.